Yes.
Cool. So I'm Simon Frid, and I'll be talking about the first part in this session, which is really about the motivation to manage and version machine learning models in Python. What does that look like? And it's a little bit exploratory. And the second part of the session, I'll be going about 25 minutes and have like a 5 to 10 minute demo. And then in the second session, Iman will be able to tell us a little bit about trusted analytics and how that can take that to the next level as a service that Intel is currently providing. So we merged sessions because we were talking about a very similar problem space. So hopefully we can make it relevant to you. All right, so this is the general overview of the session. So if you're still not sure what you're doing here, you can still get out. In the beginning, I'll be talking about 3 general use cases that explain like what are the types of problems we see in production, and then we'll get into a little bit about what are the strategies and the design considerations around like understanding what is managing models, what does that even mean, and maybe look at parallels in software version control. We'll be talking about different types of Python tools. It's not exclusively Python, but it's really focused on the Python data ecosystem. And then we'll do 2 demos. The first is a package that I prototyped, and the second will be trusted analytics. So, getting started, let's talk about motivation. So does anyone know what this is? Anyone?
It's the track car that they would do and they could go along the rails when they were building it. I don't know what it's called.
Yes, it's called a hand car. It's a pump trolley. Exactly. So this is a railroad car that is manually operated by hands. And the reason I'm showing this is because I think this is where we are in the state of machine learning today, where we have all these rails, but we're still doing a lot of things by hand. We're still figuring out, okay, we have rails, we can go places, we have that capability, but we're still missing a lot of the nuts and bolts. So the goal of this talk is, at least the first part, is to discuss strategies and tools that help organize our ML systems. With that, I want to just say, there's a disclaimer, I'm not an expert, I'm just a practitioner. So if you see things that you want to use or see ways that this can improve, just say so. Just want to say that. So let's talk about our first use case. So let's say we have a car rental marketplace. So something like Getaround or Turo, and basically what we're doing as a business is we're selling short-term rentals. And users will upload those cars, upload pictures of them to the platform. And one of the things that we would do is we would identify, are these pictures of valid cars? Are these good quality photos? Because a lot of the users will be making decisions based on those photos. So, we process the images using TensorFlow and then classify these images either into cars or non-cars. And once we're done playing around with that, we'll actually deploy it to production. And all of a sudden we take a look and we realize that there's a lot of ways to improve. So we want to iterate with our models. So if you look at the top right photo, we have this rusty car, and there's a lot of discoloration. And on one hand, maybe you don't want this type of car on your marketplace. But on the other hand, you do want to identify that it is a car. So how do you improve that? Do you want to clarify your features, maybe by introducing edge detection, where traditional deep learning techniques may not actually pick that up? And then if you're iterating through it, and then you want to actually, even if you get that first version, what about the second problem? I'd be really surprised if any model actually figures out that that's a car. Because ultimately, you may actually need humans in the loop to give feedback, to get a trusted data source, to actually improve the quality of the data that we're doing. And it might require more computational power, more GPUs. But again, we're iterating with models. So, like all of a sudden we have lots of models, and the first thing we're doing is we're spending time to develop the first one, and then we deploy it. And when after we deployed the first one, we're actually doing R&D on the second one. And after we deploy the second one, now we have to do R&D on the third one. So there's this iterative process. It takes time to deploy, it takes time to develop, and all of a sudden we have this reference problem. Which ones do we reference? Which ones do you choose for production? How do we check the performance of the models? Do we have a standard data set? Because everything that we're looking at changes over time now. So that's the first use case. So let's talk about another one. Say you're in the business of selling student loans, and what you're interested in doing is predicting the conversion rate on ads. Why do you want to do this? So you're looking for you're looking for potential college applicants who are clearly in need of some financial aid or would be searching for something like that. So you have to figure out what is the bid cost for a given user, and does it make sense whether or not that they'll convert. And if that user, are they a prospective college student? Are they ready to think about financing? So, we take a look at the demographics and we start building a stats model, logistic regression in our sandbox, and we notice a couple trends. So if you look at this, in the red, what you see is a yearly seasonal cycle around when students are applying to colleges. And in blue, you see the student loan cycle. Now, the college application cycle is pretty straightforward. Like, you can see the same peaks, you can see the same characteristics year over year of what's happening. But the student loan cycle is a little bit irregular. There's definitely some cyclical nature to it, but it's still regular. And so now the question is, like, what are we actually looking at when we're training our data set? Are we looking at the last year? Are we looking at the last 3 months? Are we trying to retrain these relative to that time period? Because if you think about that user, all of a sudden the thing that's going to be most important is the current activity of that demographic. Is everyone who's similar to that user applying to student loans, applying for student loans at that time? So you have a data problem, which is at least a data versioning problem, which is how many different data sets are we going to be training on? And ultimately, you may not have the answer on what is the best way to go about training this, so you actually need to A/B test it or use something like exploration, exploitation, multi-arm bandits. So let's look at this a little bit in detail. So say we're developing, over time, 3 different models, and now we're looking at 3 different training intervals for each one of them. And of those, we're also training one, today. We're training another version tomorrow. We're training another version the day after tomorrow. All of a sudden, it becomes a pretty big combinatorial problem where there are lots of models, and how do we reference them? How do we know what time something is going to be trained? How do we know which ones we're going to select for A/B testing? So that's the second use case. Let's talk about a third use case. You're a payments gateway. And one of the things you're doing is you're looking at, you're processing a lot of transactions, and you're essentially looking at how many of these transactions are fraudulent. So for a given type of transaction, and other information about either the user or that transaction, you want to know whether this particular transaction is likely to be fraudulent. So you develop a scikit, learn forest, random forest, and detect a variety of complicated features that your decision tree figures out, your ensemble figures out. What you get is what you get essentially is a pretty significant problem. I want to go forward one slide. I'll be back to this. You have essentially in fraud, what ends up happening is when you deploy the model, your fraud rate goes down, but this is a cat and mouse game because your scammers essentially are changing. Once they realize that their techniques are no longer working, they're going to adapt their ways so that they're not being detected. So here I have an example with Apple Pay, where about a year ago when they launched, their fraud rate increased to about 6%. And that's huge, that's huge. Like usually, they say in this article, the typical amount of fraud is about 10 cents for every $100. And so, you know, was that sustainable? Probably not. So there's this constant game of figuring out what is the signal in these data sets in order to actually make the models work. And so here what we see is that you may develop your first iteration, and based on the first signal or the first signature of whatever you're looking at, and all of a sudden it becomes obsolete because the very nature of the data, the very nature of the things you're trying to characterize is no longer relevant, even within a couple weeks or months. And this is pretty common in fraud or where there's an incentive to scam. So there's a time relevance of the features, and there's also a component where you have to do forensic analysis of obsolete models. So you want to go back and see, why didn't this work? What were we looking at? Anyway, once again, well, how do we reference any of these models? So sometimes, like, when I look at these libraries, a lot of these model libraries are like, well, you basically fit in on as much data as possible for as much you can allow for, and you're assuming that essentially as long as you don't have the curse of dimensionality, you'll figure everything out. And I just think, you know, that's just not realistic. There's a quote that I found that I kind of like. There are practical little things in housekeeping which no man really understands. Does anyone know who said this by any chance? Eleanor Roosevelt. So it has absolutely nothing to do with computation, but I thought it was still relevant to this in some ways. So we need a lot of tooling to automate and organize this information. All right, so moving forward, strategies and considerations. So let's just start with, like, what is a data science workflow typically? And this is in many ways a simplification, and but I think it still covers many of the main steps in the process. As you can see here, the yellow is essentially the data science sandbox. Blue is where business strategy decisions can be made, and red is where product and engineering actions are taken. So what we see is, you know, once you figure out what you want to optimize, you have to pull and acquire the data. You explore, wrangle, transform that, build your pipelines, you develop your models, you cross-validate it, inspect it, figure out, hyperparameter optimize what you're looking for, and then you have a question. Does this meet our goals? Does this meet our decision? Does this meet our cutoff? Is this worth going through with it? And if the answer is yes, well, you can scope it out to production. And so once you do that, and by no means is this like a very simplified system. It varies. It varies depending on how complicated what you're doing, what you're trying to develop, or what you're trying to predict. But you figure out how to replicate some of the information that you got out of the yellow sandbox, and you build that productionized system and deploy it. And when you deploy it, you have to think about monitoring and measuring, which brings us to measuring metrics. Now, this is different than your ROC curve. This is different than how well your model's performing from a fitting standpoint. This is about essentially, did my model in a real-world environment actually bring back value to the business? So this is this tracking and analytics like as if it was anything else. And all of a sudden, you know, you have to now start pulling data from there and linking it up to your models. So briefly, like if you step back a bit and you think about this as not just like a series of small steps, but actually like what can be automated. When I say automation, I'm thinking typically of like a script or a schedule or something in particular that can be repeated. It could be ETL, it could be training a model, it could be retraining a model, it could be parameter optimization. But we're all building essentially some logic out, often in our notebooks or wherever. And I guess my point is that every single time we have to automate something, we have to know what we're automating. We have to know what data set we're scaling out. We have to know what model we're retraining. And there's another component, which is how do we how do we introduce ground truth and a feedback loop into our data collection. So this is your customer support person, or this is your Mechanical Turk, or Crowdflower scenario. And so, where does versioning matter? This is where I think versioning may actually take place, either from a data set standpoint or from a modeling standpoint. When you're pulling and acquiring data, you want to know, well, over what time are we doing this? For what models is this data relevant to, right? When we're developing the model, obviously we're trying to figure out how is this different from other versions, how is it going to improve. When we're inspecting the results and validating them, we have to understand to what model that is. When we meet the business requirement, we're figuring out which model we're actually choosing to deploy. So I think actually versioning can work in the sandbox itself as an iteration towards building really good models before you choose to go through with engineering and production. When you scope out for production, you'll be spending a lot of time actually investigating what you're doing in the original flow. And when you're building out the system, you're going to be scaling out a lot of those components, maybe actually automating, retraining. And deploying, you obviously have to tell which models you're deploying and how you're tracking that. We'll go then to measuring the metrics, so you know what model is performing how well on what data set or what version of real-time data that's flowing through. And when you're doing human in the loop, again, once you're getting corrections on the model, you have to know which one that's going to. So somehow you need to reference this throughout your system. So I think we need some help. So one of the things I was thinking about is, like, how do we take parallels from software engineering and particularly version control with respect to source code. That's kind of what I did next. I went to Wikipedia and I was like, what is version control? And I came up with a couple terms that I thought stuck out, and I wanted to get those definitions, and I wanted to make a parallel to what is the required technology underneath that actually helps power that. So in this case, with a repository, the repository is where files and historical data are stored, often on a server, sometimes called a depot. So to me, a repo is essentially just a place that you need persistence and maybe a form of serialization. A lot of repos have a form of compression, but typically there just needs to be some serialization to actually be able to pull and ultimately retrieve different versions of your models and your data. Versioning, what is versioning? Versioning is when you assign either uniqueness, either version names or unique version numbers to unique states. And I think if you look at both data and modeling, that can apply. In this case, I think what you need is indexing and hashing. So you need to be able to hash your models and figure out what the uniqueness is and index it so you can look them up later on. Commits, tags, and labels. So this essentially refers to important snapshots in time. So not necessarily every variation that's going on, but the ones that actually are the ones you want to move forward with. So if you think about that previous diagram, when we're making that critical decision to go to production, what are we going to be tagging this model? Hopefully making it user-friendly and meaningful in some way to a revision number. And that's really just it's actually the same thing. It's attributes and tags. But then there's push, pull, and checkout. And I think this is this is probably where we're limited the most. There's a lot of custom work now, but it's basically the point of pushing, pulling, and checking out is to be able to create a working copy from a repo. With respect to pushing and pulling, you want to either push data or push a copy to a source of truth, or pull the most recent source of truth or something that you're missing to your local version, whether it's actually in a deployment, productionized deployment environment, or in a local sandbox. And then finally, diff. So it's essentially, if you think about diffing different code, you can see that you can see what lines are changed, what lines are added, what lines are removed, and it shows the specific modification to a document under version control. And I think when you think about it in the context of machine learning, the sky's the limit, because we're constantly comparing models, we're constantly comparing data sets. And so I think that's up to us how we want to actually go through with that as a community. So with that, let's talk a little bit about different Python tools. So there are a lot of algorithm options in Python. This is a short list, but there are a lot of ways to develop algorithms. A lot of them have sophistication. I'm not going to get into detail, but I think we can recognize a lot of these. But if we move on to something like persistence layer options, it gets a little bit trickier, because now you have to start putting all these components together from the ground up, like a bunch of Legos. So for example, something that's really common is people typically store their models on S3, similar to a URL like the one I showed. If you look at, there's something called Git large file system. That's also sometimes used for large data sets and for models, where you can actually see and use the Git terminology in order to push and pull different data. Sometimes people use Elasticsearch or other document-based stores. In particular, that allows you to index and search through a lot of different models, almost from a raw standpoint, although there is a size limit. And then some other strategies are actually using Docker and Docker repositories to actually store both your models, your data sets, and use those repos as a place to pull those images and then work on top of those Docker. And then there's something else I wanted to point out, was called Pachyderm. It's relatively new, but it's essentially a containerized data versioning, a data versioning system on top of containers, on top of Kubernetes, and it lets you actually commit different data flows actually and streams over time, as well as create pipelines. And I think it's kind of interesting, but it's still pretty low level. What about serialization options? So traditionally in Python, if you're working in Python 2, maybe you'd be using cpickle in Python 3, where that became standard. It's just pickle. You might be pickling your objects, but you might find it challenging to pickle some variations of either NumPy or large matrices or some scikit models or whatever. So then scikit-learn has its own serialization option called sklearn joblib, which does a good job of exactly that, dealing with sparse matrices, dealing with NumPy representations and other things. And then there's some interesting things called dill, cloudpickle, and pickable iter-tools. Dill in particular lets you do, essentially, lets you figure out what it serializes the class definition itself, and as a result, it lets you import or load that model without importing anything before. And then you have PMML, which is a standard in Java, but it's actually very rare to serialize things in Python with PMML. The main ways that people do it is sometimes they use a command line option called JPML, and there's an interface with that in Python. But overall, unless the library that you're using has a PMML interface itself, then it's a little bit limited. And finally, what about transformer pipelines? We don't really have good ways to serialize these. Maybe you can make a makefile and put it on GitHub, but that's another thing to consider. Indexing and hashing. So first you may hash the model. So then the question is the model unique? What about a random state? Like if you change the random seed, does that mean it's a different model? Hashing the data. Was the data unique? What about sparse matrices if they're represented in two different ways? And then you may put this in a relational database table for easy lookup, or you may put it in a key value store like Redis or DynamoDB, where you can go through a lot of different variations. Labels. Semantic versioning for the actual models themselves. I mean, how much thought do we have in terms of what is a major, minor, and a patch version for different models? It's, I think, an interesting question. Maybe a patch would be like a training step. Tags, the main tag package library that I know of is called Django Tagit, but the rest you might actually just have to implement yourself, something like that with JSON. But then you want to store metadata and create dates and relationship between different models. And where are you going to store that? Maybe through tags. And then there's notes and learnings. For example, if you think about it in terms of humans in the loop, where are you getting information from what people who aren't you giving you feedback on what's happening with your models? I think this is a great place to learn. Just might be just thinking about where do you get this extra information about these things. And finally, if you look at API components, basically, a lot of this stuff, as you can tell, these are still modular components that you still have to put in the glue all together. And a lot of shops, what they end up doing is they use ORM or a DAO-like layer with either Django or SQL Alchemy, and that actually manages a lot of these relationships. So they put it with something like MySQL, Postgres, and then be able to handle that. But there are, there are existing platforms that do a lot of this work for you. It's like Turi was an open source version that did a lot of the management around this. ScienceOps, Prediction.io, Azure ML, and there are a number of them here. And we'll get into another detail later on today with Intel's package, Trusted Analytics. Then there's asynchronous tasks, particularly like once you're training and retraining and doing large computation on the fly, or anything that actually needs to be pre-computed, you might need some sort of flow management, whether it's Airflow, Luigi, or Celery. There are plenty of others. And finally, using actually custom flows using Docker or Pachyderm to actually choose which models you're deploying and how. You might be able to use a lot of the Docker API to actually do that. But that's really it. So, as we said, that's what we have. So I guess going back to that train track, we have this hand car, this pump trolley, and we have all these rails, but we're not really using them. And I think that as a result, the ecosystem is a bit immature, and there's a lot of room for people to actually figure out what to do. So I took a stab at that, and so I wrote a package called Estimators, and it's really like a standalone client as an API for your ML repo. And the goal is to really in this version that I released is really to persist upon prediction. Use a SQL Alchemy and a local file system for now. You can find it at that repo. This screenshot was taken this morning, and I pushed it to PyPy about half an hour ago. So there's it's still a prototype, but I'd love to get feedback, and I'd love to get what you think about it. And then there's another one I wrote about a month ago, and we started hacking together, and this is essentially a Django extension for ML models. Similar, but in this case you have an active record style where you build a model, you save it. If you get a data set, you save it. You pull your data set whenever you want. And I'll give a demo in a second of Estimators, but in this case you use a Django and a local file system. There's the repo, and you can also get it on PyPy. Alright, so time for our first demo. So as a live demo, something will go wrong. You're laughing, but it's true. Alright, so does everyone see that? Probably need to make that a lot bigger.
Can you make the font larger?
Yeah. Too big?
That's good.
Why don't I just do this? Does everyone see that? Okay, cool. So, I'm going to give a demo of Estimators. I'm in an Estimators virtual LAN right now, and I'm going to go into an IPython and shell so we can use it. I have a bunch of things that load on auto load when I use IPython. I love IPython, it's really awesome. Used to use the notebook a lot, now I'm most of the time just hacking like this. So the first thing I want to do is, let's say we're doing data exploration where we're looking at different, does everyone know the data set with the different digits and we're doing classification on them? It's like MNIST. Yeah, so what I'm going to do is I'm going to start working on that and build a random forest classifier, just like that. So if everyone's familiar with scikit-learn, basically I'm loading data. And this is actually on the docs as well, but I'm just going through it just to get some intuition around it. If you look at X right now, X is a trained data set. Is that off the screen? X is our feature matrix. Y is our targets. And what I did was I split this up so we have a very simple validation mechanism. It's pretty dumb. Just everything up to the 1200th element gets in the training set, everything in the Y, everything after gets in the test set. And I fit my model on that. So here's my model. Alright? So the cool thing is, now that I did this, let's actually test it using Estimators. So here what I'm doing is I'm importing this thing called an evaluator object. And an evaluator is kind of like it makes you a plan. And what you do is you say plan equals,
That was an A.
thank you. And then I can do plan.estimator equals RFC plan.xtest equals xtest. And you can pass in quarks as well, keyword arguments into the object upon initialization. And now what I'm going to do is I'm going to say result, please work. So I'm going to say result is equal to the evaluation of this plan. This is essentially like calling a .predict method, but when I do this, it should persist all these methods and also give me the predicted answers. And so now if I look at result.y.predicted, I have my predictions for that particular data set, just as if it were calling the prediction. But I also have all the other attributes. So I have my original estimator, etc. So what is cool about this? So what's cool about it is I'm going to open my SQLite browser. So this is all put into a SQL database. And I can go now and I go to File. Yep, there we go. And I look at the browse data. Boom. So I have 3 data sets right now. So I have my essentially one of these is my X test, one of these is my it's X test, Y test, and Y predicted. If I look at my estimators table, I tell you where the location is, what is the hash of the model, and it's all persisted. And then if I look at essentially my results table, I have the relationships, so I know what was used for what model and when, and very simple. And that's about it. So you can obviously query it later on. You can build more complicated configurations around this. But that's all you get with a 0.1.0 dev pre-alpha version. And so that's the demo. So I guess we can go into our next demo then, and I'll hand off the mic.
Maybe you can get questions until I...
Oh, I guess I'll do that. So, okay. My section's done. Any questions?
I'll just disconnect you.
Yep.
Can estimators be integrated to Elasticsearch?
Elasticsearch? Yeah, it just needs a lot of work.
You might want to turn off the mic first.
Oh, sorry.
As you train.
Thank you. I mean, honestly, right now it's just configured using the SQL Alchemy engine, which typically takes relational databases. So it's not built for that. I was considering it, but the main thing about the way it's done right now is that the relationships are stored and the metadata stored in the relational databases, and that the file system, wherever it is, whether it be S3 or whatever storage layer you want, would be separate from that. So, yeah, what comes to mind when you think about Elasticsearch?
We might have some APIs that makes the searches very easy. So that way we store the predictions to Elastic. We can open up the API.
Yeah, we have to develop it. Yeah.
I like it because as a learner, right now I'm finding that the thing that I really want to know the most is how am I getting better. So if I'm working in a particular data set trying to get predictions, it's hard for me to constantly do stuff like version control. Like I can't roll out all the tools at a big company. But a project like that helps me, understand like how did I get better and iterate over time. I think it really has potential very much at the start for like really helping out people individually who want to know just how well have I iterated over time. Like learners love that stuff.
Yeah, I think that's definitely a major application, and like a piece of inspiration is how many times I think a lot of us are reinventing the wheels when it comes to projects like this, and just try to create some open source packages around that.
Great. So we're going to have to hold the Q&A till after. We want to get finished before 2:55. Thanks, Simon.
Okay, so I'm going to show you one solution we developed. I'm Iman, I'm from Intel, so I'm a product manager of the Trust Analytic platform, which is a solution that try to help both data scientists and application developers to build analytics solution end-to-end. And one of the issues we came across, and one of the pain points is exactly what Simon was presenting, is how to handle different versioning of models and deploy to production. So Trust Analytics is an open source free platform. You can check it at trustedanalytic.org. You can ask for a test drive if you want to just try it, or you can download it yourself. It's a GitHub project, it's a big project, but you can install it yourself. There are no hidden fees. I'm going to show you, this is that, or the Trust Analytic platform. I'm not going to go through all the workflow, but focusing on how to handle models and push models to production. So in general, when you get into TAB, the first step is you get your data in. So TAB support ingesting data from multiple sources, so you can have it on S3, so you provide a link, or if it's like relatively small data and you have a path for it, you can go and get it. Or you can schedule a job to import your data into the platform if it's like in a SQL, some legacy SQL systems. whatever you end up doing, your data will live here in a catalog. And then as a data scientist, you're gonna go instantiate a new Jupyter notebook and start doing your machine learning or your data science magic on the data. I'm gonna show you one example here. This is a Python script. So you develop your model here. We have our own library for machine learning. It's called SparkTK. It's optimized for Spark and it's distributed. And you can use it, or you can use your own libraries as well. This is like just a typical data science script, doing some data exploration, changing some data values in the columns, doing some visualization and histograms. And then for this problem, they decided that SVM model is a good model for this specific use case. So they developed a model. And then in our scripts, the last step is always to publish the model. And publishing the model it makes it available in tab catalog of models. So this is touching on a problem that Simon brought up. You have all these models that you work with, and usually the process is too manual. Every data science is working with some models. Tab is trying to create this collaborative environment where everyone can put their model that are ready for production. So publish this model here will make it available in Tab. So if you go here and you filter by models, this is like in my account, I have one model, a linear regression model. And if you look at it, it's basically a tar file, so it was zipped and packaged for you. You don't have to worry about that as a data scientist, and it is now living on the tab storage. In our case, it's HDFS storage. So now you're ready to use it. You either pick up this tar file and put it in an application, but even we try to make it easier for you. So we developed what we call a scoring engine. So we go here. Tab scoring engine is just a service that takes this tar file, package it, and expose it as a RESTful endpoint. And this is basically what developers are interested to have from a data science. They need an artifact that they can use in their application. They don't care how it was built, how it was trained. They need to know how to use it in production. And instantiating that is as easy as saying, this is my scoring engine instance. And I say, my tar archive live on this HDFS something. So I just put my my model here. I'm going to show you an example in our documentation. So here I just named it and put the tar archive and give the path to the model. What this does is that it creates you an endpoint that has this format. So you have a scoring API. You just send it a data, array of elements usually, and get the scoring value. So we got a couple of things from that. You encapsulate the complexity of the model. You make it easy for developers to understand how to use it, because software developers don't need to understand the data science behind it. And make it very easy for people to use it in applications. And we support that as well in Tab. So application development is also, or application deployment is also supported. In this version, it's Cloud Foundry. This is version 0.7 of Tab. Coming by the end of this year, we're going to go to Kubernetes and a totally container-based architecture. But it will be the same workflow. You go, you install Cloud Foundry in your machine, and you develop your application. You have this service, a scoring engine service. You bind it to your application, and then you push it to tabs. Your application will live here somewhere. So it's deployed on the cloud. So this is like end-to-end solution. What we're working on, this is the current version. What we're working on is a model catalog. It's empty for now. But you'll have a way to, for a specific model, you have all kind of files related, and you have some kind of versioning. So you can say, This is a version I developed, for example, I'm building a model for classification on the US population. And then tomorrow I'm going to apply my model on the China population, and I need to keep both of them. And maybe as a data scientist, I consider just two versions of the same model. So you'll be able to have all this versioning, and you can roll back to a previous version. You have a scoring endpoint for each, so you can have some A/B testing. You want to also include different versions in different applications. So this is basically it. Just one solution that we're working on. This is open source, open for suggestion and contribution from the community. We're trying to have the community drive where this goes. So this is one requirement that came up from a data scientist, from our data scientists, and we're still working on more how to support easy what do you call traceability or provenance of models. So when you have this kind of history, it's easy to go to a model and know how it developed over time. Because from our experience, the business people are not really interested in just the end result. They want to know how you built your model, what assumptions you used, what feature you used for the prediction and so on, especially in the healthcare domain. So this is my demo. If you guys have any questions? Yeah.
So did I get you right there? Yes.
Louder, please.
Okay. You said what lives on the cloud and your HDFS system?
Yeah, so
Can you repeat the question?
yeah, so she's asking about the cloud aspect of TAB and what lives on the cloud. So TAB underneath is based on Cloudera Hadoop distribution, CDH. So HDFS is our first class citizen for data management or storage, and it's all cloud-based. So you can install TAB on AWS, for example, and then you instantiate it on AWS and you have the Cloudera services running, or on-premise. So we support OpenStack for on-premise installation, and soon we're going to support bare metal, so if you don't want a cloud support. But the underlying data infrastructure is HDFS.
So, let's say you have two models, you run two models, and you have visualizations corresponding to each model. Do you have the ability to see the visualizations, compare it side by side, or?
Yeah, that's a good question. Currently, we don't. We depend on the fact that data scientists already have their own workflow to build a model and do the visualization. You can do everything programmatically because you have Python in it, so you can do it. But tools-wise, we see that as outside the scope of that. But what's coming up is like if you have versioning, you can like compare two versions, and I'm like, yeah, this is a version uses data set timestamped at this time, and this is a data set at the other time. So you have some kind of traceability, but not the visualization part.
So you would just pull the results to say Excel or something and just compare
Yeah.
if you want to.
Yeah, you can do that. Yeah, you can use your own tool. You can see that as like a repo for production artifacts. Whatever you wanna deploy eventually will live in that. The process of developing, we support it to some extent by just providing a notebook, like Jupyter, but eventually we see like data scientists, they have their own toolbox already. They can use that. Good questions. Other questions? Yeah.
How easy would it be for a single person to roll this out, like you said, on like AWS, like in terms of like effort?
For a single?
Like in my use case, and this person who would want to use this, perhaps it's open source, right?
Yeah,
So
it's open source.
how hard, like in a practical sense, how hard would it be for me to like take this, learn it, and then put it up on an AWS so that I myself can use it?
Yeah, so we make it really easy to deploy on AWS. It's just like you fill a form, you click a button, and say, I want to tap on AWS, and that's it.
All right, I like it.
You define like capabilities you need in your cluster. It's a bit pricey because it's open, it's a big data platform. So expect to have, like you need like at least what Hadoop is requiring. You need powerful resources. But it is really as easy as filling a form and clicking a button.
Thank you.
Yes.
May I direct a question to the prior
Yeah,
speaker,
sure.
please? If one follows the algorithm the procedures that you described, it would perfectly admit of all sorts of prejudice. For example, one might reasonably say, geez, let's systematically exclude credit applications from people with funny mustaches.
Yeah.
But you can substitute for that any number of other social pre-decision patterns. And lots of companies would go along with that quite readily. Indeed,
Right.
that's a disease of our culture. Do you, I'm not saying, I don't have an answer with my tongue, I'll be amazed if you do, but do you have some insight into how to address this? Because what we are doing, in fact, risks working hand in glove with these social diseases.
Yeah, I think like with that type of thing, I think the key is I saw a couple things around this before. So one is creating essentially benchmarks for checking for prejudice. When, as a data scientist, you want to see, am I, for example, is my model biased towards a minority group? Is my bias towards gender? You create a benchmark around that and you test that. So I think actually the first part is hire people who work ethically, understand ethics, and are motivated to build algorithms or ones that are essentially ones that have the greater interest, not just something that optimizes a small margin, and have them be also critical thinkers. And then finally create systems that hopefully, I think with the right automation, you can actually also react to the types of things you're saying. Over optimization, or these types of things could also say, well, we don't really need to improve, from 91.2% to 93%, because it actually, we're not, what we can do instead is we can publish how our model is actually behaving
Sorry guys,
ethically.
we're out of time, so
So, I don't know. Yeah, I don't have a card, right? So my name is Simon Bridge, my last name is I go by.
I don't know the name of it.
Wasn't on film.
The one where everybody brings their cans. Oh, this is good. What? Self-driving car ones. And the self-driving car ones are even. So they're about to get Sorry, it took stats in college, and I don't think it's actually It's okay, I'm in R lane. Oh, that's another meetup. R inverse. It's called R lane. I went to the E's R.
Hi, I wonder if they're